Hi friends, welcome back. Today we are going to solve Codeforces problem, space navigation. Before we start looking into the details of this problem, examples and the Java solution, I want to mention that my channel is dedicated to help people who are preparing for Java interviews and coding interviews. On my channel you will find a lot of helpful videos that will be helpful in your Java J2E preparation and in your coding interview preparation. You will find over 200 solved different varieties of coding problems which were previously asked by big tech companies like Google, Amazon, Facebook, Apple, Microsoft, Yahoo, and many others. And those coding questions are selective in the sense that they cover important coding questions varieties such as BFS, DFS, matrix problems, binary search tree problems, graph problems, dynamic programming problems, as well as different string related coding interview questions. So if you are preparing for any Java interviews or coding interviews, please subscribe to this channel now. This channel can definitely help you in your job interview preparation. So please subscribe it. So let's go through the space navigation problem statement first. You are dreaming that you are traveling to planet named Planetforces on your personal spaceship. Unfortunately, its piloting system was corrupted and now you need to fix it in order to reach Planetforces. Space can be represented as xy plane. You are starting at point 00 and Planetforces is located at point px/py. The piloting system of your spaceship follows its list of orders which can be represented as a string S. The system reads S from left to right. Suppose you are at point xy and current order is Si. If Si is equal to U, then you can move up, right? It's a up move basically. So you can reach from xy to xy plus 1, right? So you are moving 1 unit up basically. D means you are moving 1 unit down, R means you are moving 1 unit on the right side, and L means you are moving 1 unit on the left side. Since string S could be corrupted, there is a possibility that you won't reach Planetforces in the end. Fortunately, you can delete some orders from S, but you can't change their positions. Can you delete several orders, possibly 0, from S in such a way that you will reach Planetforces after the system processes all orders? So in input they have given us, for example, in this first example 10 comma 5. So 10 is basically px and py, right? So it is the coordinate of where that Planetforces is located, right? And then second line contains the string s, which is list of orders, right? So it's kind of a moves basically, you can say, right or up or down or left. So it's kind of a list of orders they are saying. It's guaranteed that the sum of s over all the test cases does not exceed 10 raised to 5. And in output we have to output yes if we can delete several orders or 0 order from s in such a way that we will reach Planetforces. If we cannot reach, then we have to output no. So let's just take this first like this second example on whiteboard, and we will first understand the problem and solve the problem here. So we are given that the Planetforces is located at position 1 comma 1. So this is where the Planetforces is located, right? And we are first our location is at 00, right? So we are located here 00, right? So uh, we have to check if we can reach the Planetforces. So to reach the Planetforces, so if for example we are allowed to delete a couple of the moves from this string, right, to reach to the from this point to this point basically. So let's just assume that if we are deleting these moves, right, and L, right, so we delete this move, so we just kept up and right basically, right? So it means that we can go up by 1 unit here and then right, so it means that we can reach the Planetforces by deleting these moves. So we have to output yes. So this is as you can see, this is the answer for the second example, right? It is giving us a yes. So let's so basically how we are going to solve this problem. So the problem is basically we want to reach from 00 to the point that is given to us, right, by using some moves basically. So what we will do to solve this problem is we will first calculate the number of, like, calculate our moves from here to here, right? So to find out how many moves we will need actually to reach from 0 0 to the given point, what we can do is um, the given point can be negative also, right? So we will actually try to understand our, first thing we will try to understand is our x coordinate, right? So xy positions are there. So if we want to, let's say this is 1 comma 1, right? This is 1 comma 1. So if we want to reach to 1 comma 1, so this is px, right? This is px and this is py basically, right? And this is, let's say, x and y. So we are x and y here. So we will compare the px and py, px and x, sorry, px and x we will compare. So 1 and 0 0 we will compare, right? So it means that we will compare the difference and we will uh, create one map, right? So what it means is the difference is 1, right? So it means that we have to go 1 unit on the right side basically, right? So we will create one map. So as you can see, this is how the map we will create. So right 1 basically we will see, right? After that we will compare the py with the y. So py is 1 and y is 0. So it means that we have to go 1 unit on the up, right, to reach this point. So we will again take count it as one move, right? So up is 1 basically, right? So we will create this map basically. So this is the our required moves, right? So these are the required moves that we have to make from our original location 0 0 to reach to the Planetforces location, right? So we will create one map like this by comparing the px and x and py and y coordinate, right? So we will know we have to go up or right or left or down basically, right? So other cases can be, so let's just see some other cases, right? I'll just quickly draw you here. So let's say this is our xy plane, right? So we are here at 0 0, and let's say the Planetforces location is given at, let's say, -2 here, sorry, this one is a -2 comma 2, right? -2 comma 2. So in this case we have to go left by 2 units, right? Left by 2 units and up by 2 units, right? So in this case it means that we will have, our map will have left is equal to 2 and up is equal to 2, right? Up is equal to 2 basically, right? So this is how we will first create our map of required moves that we will require to move to the Planetforces position from our 0 0 coordinate. So in this example we will get a map like this, and we will also create a map from the given string. This is our given string, right? Up, then d d d r l l l. So we will create another map. So this is our another map we created, right? So as you can see, r1, so here we will have a count of how many moves are possibly given, right? So r is 1, d is 3, u is 1, as you can see l is 3, right? So this is a possibility of moves, right? After we have both this map, let's say map 1 and map 2, right? What we will do is we will compare the each required move. So for example, r is equal to 1, so we should at least have r is equal to 1 here in this map 2, right? After that we will compare u is equal to 1, so we will have at least u is equal to 1, right? At least u is equal to 1 is required. If it is not it is not there, then it will not be possible basically to reach to that point where Planetforces is located, right? If both are satisfied, then it means that we can reach to Planetforces, and in that case we will say yes basically, right? Yes, we will say. If it's not possible, then we will say no. So for example, if we remove u from this, right? If we remove u, if u is not there in the given string, let's say for example this given string is just d d d r l l l, right? In that case our u will be 0 basically, right? So u will be 0 here in that case, right? Which means that we cannot reach to the Planetforces position, because we can go right, we can go down, we can go left, but we cannot go up basically, right? So it means that we can never be able to reach that, right? So that we will test it on in our unit test cases. So let's just take it out. So now let's just go ahead and this is the logic to solve this problem of space navigation. So let's just go and take a look at the Java code now. So px and py is given to us. Also input string is also, this string is given to us. These are the moves or list of orders they say, and xy is 0 0, that is also given to us. So first thing is we will create two maps. One is required moves map. That required moves map is this one, right? This is the required moves map, means how many moves we will require to reach from 0 0 to that point. So we will use that map, and then given map is the map that we will create from the string. So this m2 is the given map, right? So what we will do is we will compare x with px, and then if x is greater than the px, right, then in that case we have to move on the left side, right? So we will just subtract x here, x minus minus, and we will increment left moves here, right? So merge, we use maps merge hash map as a merge function. So this merge function we use, and then we use this java by function for addition. So essentially what it does is, it after this while loop, it is calculating how many left moves we have to make basically, right, by comparing x and px. Similarly, if x is less than px, right, in that case it means that we have to go on the right side, right, because px is on our right side. So that's what we will calculate, how many right moves we have to make. Similarly, if our y is less than, if our y is greater than px, that means that we have to go down because we are on the up basically, right? For example, instead of let's say we are at 0 0, and the location we want to go is this one, right, which is like down, right? Here we are going up basically, right? Here if we are want to go down, then that's what we are checking here, right, this one. And if our y is greater, if it is less than py, means py is up above us basically. If it is above us, it means that we have to go up basically. So that's what we are counting here. So we will prepare our required moves map at this. After this four while loops are done, we will get this map, right? It will give us how many right, up or left or down moves are required basically, right? So that's what we are doing. After that one is done, we will take the input string. The input string is this one, right? And then we will again create a map of the moves that are available, right, or given to us. So we are looping through character by character, and we are just using merge method, and we are creating a map, like given map, right? So the given map will look like this, right? From this one, our given map will look like this, right? R1 D3 U1 L3. From this given string we have created that map. Once both of our maps are ready, now we can actually, we have to compare. What we will do is we will compare the required moves. For example, r is equal to 1, right? One move is required. Up is equal to 1, up is 1 required, r is 1 required. So at least those moves should be present in our given moves, right? So that's what we are going to do here. So we are going through the required moves map key set, and we are making sure that required moves map is less than or equal to the given move, right? If it is less than equal to given move, we will keep continue and keep checking for remaining moves, right? If it's not less than or equal to the given moves, it means that we cannot reach to Planetforces basically, right? We don't have enough moves that are required to reach to Planetforces position. So in that case, we will just output no, and we'll just return from this function basically, right? Otherwise, we will keep checking for all the moves in the required moves map, right? If everything is available in the given map, in that case, we will print yes here after the for loop is completed, right? So let's just execute this code quickly. So as you can see, we are getting yes, which is the correct answer. So we have taken the second example, and we are getting yes, which is the correct answer. So we will just modify our example little bit. Now we know that we need one up, right? One up move is required. As you can see, this is up move, right? So we will just remove that. So in that case, if we remove up move, then we should get no as our answer. So let's just remove this up move and again execute it. So as you can see, we are getting no as our answer. So apart from that, let's take some other example from here. Let's take the first example 10 5. So let's take this example 10 and 5, and this is the string that is given to us. So let's execute this. So we are getting yes, which is the correct answer we are getting. So our test case is passing. Let's take one example where no is the answer. So let's take -1 and 6. It should be a no answer. So this is -1 and this is 6, and let's take this. Oh, okay, you are right. Let's just make sure it's correct. You are. So let's execute this one. So this is a negative test case, it should give no. So we are getting correct answer. So this is the way we can solve Codeforces problem, space navigation. So what we did, let's just quickly recap this. So we have created a map of the moves that are required to reach from our given like 0 0 position till the position where that uh, where we wanted to reach, right? So we will create those moves basically using that four while loops that I shown you. So this is the map we will get from that, right? And after that we created another map from the given string. So this is that map m2, right? And then we just did a for loop, and we made sure that all the required moves are available into our given moves, right? If it is the case, then we'll just say yes, otherwise we will say no. If you are new to my channel, there is a dedicated Codeforces playlist on my channel which has a lot of solved Codeforces problems explained with examples and Java code. There is another big playlist called as lead code and lean code solutions on my channel that has a lot of lead code and lean code solved problems which were taken from previously asked interview coding questions by Google, Amazon, Facebook, Yahoo, Microsoft, Apple, and many other big tech companies. So if you are preparing for coding interviews, you can take a look at these both playlist, can definitely be helpful. Also, if you are preparing for Java telephonic interview rounds, there is another playlist called as Java interview. You can check it out. It has a lot of frequently asked Java interview questions explained how to answer those questions. There are also another videos related to Java architecture, Java design patterns, as well as Java string related coding interview questions. You can check it out. Um, if you find this video helpful, if you like it, and if you like the way it's created with whiteboarding examples and Java code, then please give it a like. Also subscribe to the channel. Your subscription to the channel is really important for the channel because that is the way the channel can reach to more people who need help in solving coding problems. They can also watch this video and learn from this video how to approach different varieties of coding problems and how to build the logic to solve the problems and what data structures of Java to be applied to solve different coding problems. So if you like this video, please give it a like. Also, if you have any questions regarding this video, please put your questions below the description. I'll give you the link of my GitHub repository. You can check, there are a lot of solved coding examples there in the GitHub repository. You can check it out. Also share this video with your friends and colleagues, and thanks for watching this video.